Okay, guys, let's do the homework. Just be careful, learn how to do this method because your exam is in a couple of weeks, and to be honest, your exam will only be, or 90% of it, maybe 85, will be from this homework and the last homework. Just learn how to build your cascade diagram, how to determine your targets, and how to build your heat exchange network, which is the focus of this week's lecture and what this homework is about. And next week will also be a review week as well. So, just try to learn it and try to be comfortable with it before the exam, because it's not the type of thing which you can pick up while studying during the test, right? It's not going to work out. Okay, so in homework number 4, what we're doing really is we're taking the results we got in homework number 3 and we're building the heat exchange networks for them, okay? And yeah, this is very important to know. Okay, so let's start with problem number 1. If you recall, problem number 1 from homework number 3, we had 4 streams. And we have our heat exchange targets already determined. So let's build the network. So again, step 1 is we have to sketch your streams from. So this the approach will always be the same. So step 1 in this case, let's change the color. Let's use let's keep it in black for now. So again, the way to do it is I'm going to have H1, and H1 goes from 180 all the way to 60. Then we have H2, which goes from 150 to 60. And then we also have C1, which goes from 30 to 135. So from 30 all the way to 135. And C2, which goes from 80 all the way to 140, right? 140. And step 1 will always be to sketch them out like this. And if you recall, for this problem, we had our QH was 80 kilowatts, and we did this during last week. Our QC was 50 kilowatts, and our pinch temperature was 80 degrees Celsius. And something you should always remember about these problems is these are the rules of the game. Should never forget them, and these will really govern how you're gonna design these systems, right? So rule number 1. Let me erase this. So the rules are there, or okay, where's the mouse? Here we go. Above the pinch, when doing our matching, our CP hot has to always be less than CP cool, and there is no cooling. This is very important. And then below the pinch, our CP hot has to be greater than or equal to CP cold, and there is no heat, okay? No heating. And these 2 rules are extremely important when building your networks, okay? So again, step 1 is to always just sketch out your streams. Step 2, we know our pinch point is 80 degrees Celsius, so I'm going to draw 2 lines down the middle of this diagram. So I'll just draw 2 lines here. Right, and maybe let's draw this out properly. Let's give ourselves some space when drawing, and yeah, you should always give yourself some space when drawing because we will be sketching. So 180 to 60, and then the second thing is from 150 all the way to 30. Then we said this stream is from 30 to 135, 30 all the way to 135. This is C1, and C2 is 80 to 140. 80 to 140. Step 1, we said we're going to sketch them. Step 2, I'm going to draw 2 lines for the pinch point, right? These 2 lines are for the pinch point, and again, and I'm going to write the pinch temperature. So for the hot pinch, so because your cold pinch is 80, your hot pinch will be, or your hot pinch will be your cold pinch plus delta T minimum. In this case, delta T minimum was 10, so our hot pinch was 90 degrees Celsius. So this will be 90, 90, 90, 90. This is the hot pinch for the hot streams. And then for the cold streams, for C1 and C2, my pinch point is 80, 80, 80, 80. And this is always the second step. After you draw your streams, I'm going to draw 2 lines for the pinch. And then I'm going to write my temperatures for the hot pinch. I'm going to write the hot pinch temperatures and the cold pinch temperatures. And then the third step would be to refine this diagram. Let's have a look here. 60 to 90, 90 to 180 makes sense. 30 to 90, 90 to 150 makes sense. 30 to 80, 80 to 135, okay. 80 to 80, 80 to 140. So this 80 to 80 means that there really isn't anything below the pinch for stream C2. So actually stream C2 starts at the pinch. So let's refine this diagram, or let's remove, let's redraw stream C2 such that it only starts from the pinch upwards, right? And this will be stream C2 goes from 80 to 140. And once we clean up this diagram, we're ready to do the matching of the streams. And in order to do the matching of the streams, remember that we're using these 2 guidelines, CP hot, CP cold. So let's write our CP values next to the streams, right? So I'm going to write the CP. In this case, for H1, the CP was 3. For H2, the CP was 1. For H3, the CP was 2. And for for C1, the CP was 2. And for C2, the CP was 5. So now I have my CPs. Another step which is very useful is to determine the amount of heat available above the pinch and below the pinch for every stream. And just recall that Q, or delta H available, is equal to delta T multiplied by CP, right? So for this guy above the pinch, 180 minus 90, that's 90 multiplied by 3. So I have 270 available above the pinch. Here, 150 to 90, 60 multiplied by 1. So I have 60 available above the pinch. Same here, 135 to 80. So at 55 multiplied by 2, this is 110 kilowatts available. And 80 to 140, this is 60 multiplied by 5. This is 300 kilowatts available. Let's look below the pinch. 60 to 90, that's 30 multiplied by 3. So I have 90 kilowatts here. 30 to 90, that's 60 multiplied by 1. That's 60 kilowatts. C1, 30 to 80, that's 50 multiplied by 2. So I have 100 kilowatts here, and then there's nothing for C2. And now let's do the matching. So above the pinch, I can match them by CP hot has to be less than or equal to CP cold. So I'm going to start at my first hot stream. H1 here has a CP of 3. So can I match H1 with C1? No, because the CP of the hot stream here is larger. It has to be smaller. Can I match H1 with C2? Yes, I can. So 3 is less than 5, so I can match them. Once you make this determination, just draw your heat exchanger. And I'm transferring, so this stream has 270. This stream needs 300. So I'm just transferring all of the 270 from the H1 to the C1. This way H1 is done. So I'm going to check H1 here. Now let's have a look at H2. Can I transfer from H2 to C1? CP, the hot CP here is 1, the cold CP here is 2. Yes, so I can make this transfer. So I'm going to connect this heat exchanger to this, or this stream to this stream using a heat exchanger. And stream H2 has 60 kilowatts above the pinch. Stream C1 needs 110, so there's 60 kilowatts to be transferred. Okay, so now I've satisfied both my hot streams, so I still these two cold streams still have some energy, which has to be provided, right? So let's have a look at C1. So for stream C1, it needs 110. I only provided 60, so I'm going to add a heater, right? And always remember, there is no cooling above the pinch. You always have to have heating on your cold streams. So I have QH, and this QH will be 50, right? 50 plus 60 is 110. And then for the second cold stream, I'm going to add a second heater. So 270 from 300, so I need 30. And when I look at the overall heating capacity or heating requirement above the pinch, and I compare it to my calculations. So if I have a look here, summation QH will be 30 plus 50, which is equal to 80 kilowatts. And this number should always match the number you got from your cascade diagram. If they don't match, you did something wrong with your calculations, just go and verify it. Okay, so now above the pinch, we're done. Let's have a look below the pinch. Let's have a look below the pinch. So in this case, below the pinch, I need CP hot to be greater than CP cold. So let's have a look at the first hot stream. The CP for this stream is 3, and I only have one cold stream available. The CP for this stream is 2. So can I do a transfer between these two? Yes, I can. So I'm gonna connect these two guys. And this stream here has 90. This stream needs 100. So I'm gonna transfer all the 90 from the hot stream to the cold stream. This way this is checked. Okay, let's have a look at the second stream. It's a second hot stream. Can I transfer from H2 to C1? The CP for H2 is 1. The CP for C1 is 2. So the CP hot is not greater than the CP cold. So this transfer cannot happen. Okay, so here I have 60 watts, which I need to cool. And here I have 10 watts left, right? Or 10 kilowatts left, which I need to deal with. And you need to remember that below the pinch, there is no heating, right? So I cannot heat the stream. This is not possible. So I need to find a way to satisfy the remaining 10 watts somehow. So in order to do this, as we discussed this in the slides, I'm going to do a split stream. So I'm going to split this stream, and you can calculate the split fraction. You can calculate the split fraction. And then I'm going to connect this stream to the split stream. And the CP of the split stream is less than 1, okay? This is very important so that you don't violate this rule. And I'm going to transfer 10 kilowatts. So if I do this 90 plus 10, so I'm satisfying C1, and I have 50 here, which have to be dealt with. So here I'm going to add a cooler on H2, QC with 50 kilowatts, and this number has to match this number, which is the case here. So this is the correct system. So it seems complex, I know, just go over the exercises we went with on the slides and try to do this slowly, repeat it until you get it, okay? So let me save this guy, and let's clear this window. Okay. Now let's have a look at problem number 2. Again, the approach will be the same. So in this problem, if you recall, we have QC was 60 kilowatts, which we did last time, or QH, sorry, was 60 kilowatts. QC was 225 kilowatts, and the pinch temperature is 140 degrees Celsius. So let's draw the streams. First step is always to draw the streams. So I have H1. It's going from 180 to 40. 180 to 40. I have H2 going from 150 to 40. 150 to 40. I have C1 going from 60 to 180, going from 60 to 180, and then I have C2 going from 30 to 105. C2 going from 30 all the way to 105. So this step one, I just drew my streams. Step number two will be to just draw the two lines with a pinch. So I'm gonna draw my two lines here, two small parallel lines. Here we go. Oops. Anyways, just draw it efficiently. Let's draw this line properly. Okay. Okay, and then I'm gonna write my pinch temperatures here. So this is the cold pinch, remember? So my hot pinch will be 140 plus delta T. In our case, the delta T was 10. So the hot pinch will be 10. So this will be 150, 150, 150, 150. Then for the cold streams, it will be 140, 140, 140, 140. Step number two done. I just drew my lines with a pinch. And then step number three, I'm going to clean up this diagram. Let's see if this makes sense. So I have 180 to 150, then 150 to 40. That's fine. 150 to 150, 150 to 40. So H2 does not exist above the pinch. So let me clean out H2. So H2 actually only starts or only exists below the pinch. So I'm gonna redraw H2 only below the pinch. And this will be H2. Let's have a look at C1, 60 to 140, 140 to 180. Okay, that's fine. 30 to 140, 140 to 105. This does not make sense, right? It's going up and then going down. No, so C2 actually only exists below the pinch as well. So let's clean out C2. No. Let's clean out C2. And C2 will only exist below the pinch. So I'm going from 30 to 105 below the pinch. And the pinch point is 140, so we're completely below the pinch. Okay, so now we have our streams. We're ready to do the matching. So first thing we need to do, again, let's rewrite the rules. So we said above the pinch, CP hot has to be less than or equal to CP cold, and there is no cooling. And to below the pinch, CP hot has to be greater or equal to CP cold, and there is no heating. Okay, very important to remember. Let's write our CP values. So CP values, let me just let's clear up this guy here for a second. And we already know the T pinches, right? So I'm gonna write the CP values here. If you recall, they were 2, 4, 3, and 2.6. These are the CP values from your homework, right? Yeah, 2, 4, 3, 2.6. Just be careful you're doing it properly, because if the given table you have the cool strings on top, just don't let this confuse you. Okay, second thing we're going to calculate, let's calculate the delta H's above and below the pinch. So delta H above the pinch and delta H below the pinch. Just calculate how much heat is available in each stream above and below the pinch. So in this case, 180 minus 150 multiplied by 2, so 30 by 2, this is 60. For H2, there's nothing. For C1, 180 minus 140 is what? 40 multiplied by 3 is 120. So these are the heats available here above the pinch. Then below the pinch, you do the same thing. 150 minus 40, this is 110 multiplied by 2 is 220. 150 minus 40, again 110 multiplied by 4, this is 440. 140 from 60, this is 80 multiplied by 3, this is 240. And then 30 to 105, this is what? 75, right? 105 minus 30 is 75 multiplied by 2.6. This is 195. So I have 195 kilowatts available in this stream. Okay, now let's start the matching. So we have everything. We have all our metrics ready. We can start doing our matching for this problem. Okay, so let's go back to red. Let's have a look above the pinch. So above the pinch, CP hot has to be less than or equal to CP cooled. I have one hot stream, H1, CP of 2. One cool stream, C1, CP of 3. So CP hot is smaller than CP cold. So I can match them. So let me connect them with a heat exchanger. And this hot stream has 60 kilowatts. This cold stream needs 120. So I'm going to transfer all the 60 from the hot stream to the cold stream. So each one is done. There's no other transfers possible. So I'm going to add a heater. Again, above the pinch, you're only heating, you're not cooling. And this heater will be 60, provide the remaining energy. So 120 minus 60 will be 60 kilowatts. And as you can see, QH here matches this QH, which means our calculations are fine. Okay, now let's have a look below the pinch. And again, remember, below the pinch, CP hot has to be greater than CP cooled. So let's have a look at the first one. CP hot is 2. And C1 CP cooled is 3. So this transfer is not possible. Okay, let's have a look at the second one. 2 with C2, this is 2.6. This is also not possible. So I can't really transfer any heat from H1 to C1 or C2 unless I use a split stream, but the split stream determination is usually made at the very end. So let's have a look at H2. H2 has a CP of 4. So let's have a look at H2 to C1. Is 4 greater than 3? Yes. So the CP of the hot is greater than the CP of the cold. So I'm going to connect them and transfer some heat. So the C1 needs 240. H1 has 440. So I'm going to transfer 240 from H1 to C1. This way, C1 is done, and in C1 is done in H2, I still have 200 left. So now let's have a look. H2 to C2. H2 has a CP of 4. C2 has a CP of 2.6. 4 is greater than 2.6. So in this case, I'm going to connect them with a heat exchanger. And so this H2, I already used 240. I have 200 left. C2 needs 195, so I'm going to transfer all the 195 here. So this is done. So both my cold streams are done. So now I'm going to look at the cooling here of these hot streams. So for H1, I need to cool it completely. So I'm going to have a QC of 220 to provide all the cooling. And then for H2, so I have 240 and 195. This is equal to 435, so I still have 5 left. So I'm going to have a small cooler here with only 5 kilowatts. And my summation of my cooling duty is 220 plus 5, 225 kilowatts. Okay? And this matches this number, so this means this network is valid or is correct. So again, same approach, you just follow the steps, take it slowly. It's just algebra matching all the stuff until you get your answer or the correct answer. All right, let's save this guy as well. Now let's move on to problem number 3. Okay. So for problem number 3, is an interesting problem. Our QH was 0. Our QC was 538.1. And our second, this thing is stuck. Okay, and then kilowatts, of course. And our pinch point was 570 degrees Celsius. Yeah, it was 570 degrees Celsius. Okay, let's have a look at our streams in number 3. So we had 3 hot streams and 3 cold streams. let's sketch our streams. So again, I have H1 going from 440 to 150, right? So it goes from 440 all the way to 150. We had H2, which goes from 520, 300, 520 all the way to 300. H3 was from 390 to 150. Then we had our three cold streams. So C1 went from 100 to 430. Let's throw it here. 100, 430. C2 was from 180 to 350. And then finally C3 was from 200 to 400. Okay. So C3 in this case was from 200 all the way to 400. Okay. And then let's draw our pinch point. And one thing you're going to notice about this pinch point is it's higher than all of these temperatures. So this entire problem is below the pinch actually. So let's just draw the pinch point. So in this case, the entire problem is below the pinch. So you could just know it, or we can draw the pinch point. So I'm going to draw the pinch point in a way which doesn't really violate this diagram by a lot. Okay, this violates it by a lot. Okay, let's try to draw this line properly. Okay, here we go. And because all of these temperatures are, so this will be 440, this will be 520, this will be 390, because all of these temperatures are significantly lower than this. This will be 430, 350, 400, right? Because all these temperatures are lower than our pinch temperature of 570, right? Okay, let's write our metrics here. Since the entire problem is below the pinch, first of all, let's write the rules. I'm gonna always write the rules. It's good to remember. Above the pinch, we have Cp hot is less than or equal to Cp cold, and we have no cooling. And the second thing is below the pinch, we have Cp hot greater than Cp cold, and there is no. This entire problem is below the pinch, so just take note of that when solving this this thing. And let's have a look here. So let's write our Cp values. Let's see. We have strange numbers here. 2.8, 2.38, 3.36. 2.8, 2.38, 3.36, and then for my cold streams, they are 1.6, 3.27, 2.6. Okay. And another thing we're going to calculate, or I highly recommend you always do it, is to calculate the delta H available in each stream. So I'm going to put it on this side because, you know, space things. So I have 440 minus 150 multiplied by 2.8. So this will be 440 minus 50 multiplied by 2.8. This is 812. 812. For H2, it's going to be, let's have a look, 520 minus 300 multiplied by 2.38. So it's going to be 523.6. For H3, It's 390 minus 150 multiplied by 3.36. It's going to be 806.4. For C1, it's 430 minus 100 multiplied by 1.6. So it's 528. For C2, it's 350 minus 180 multiplied by 3.27. So this is 555.9. And the last one, 400 minus 200 multiplied by 2.6. Says just 520. Okay, so we have the heat available in each stream. We have our CP for each stream. So now let's do the matching. If you recall, this entire problem is below the pinch, so CP hot has to be greater than CP cold. So let's have a look at the first hot stream right here. So H1, CP is 2.8, first hot stream. Let's have a look at the first cold stream, 1.6. Can I connect it? CP hot is greater than CP cold. So I'm going to connect my first heat exchanger from H1 to C1 right here. And how much heat is it transferring? So this stream has 812. This stream needs 528. So I'm just going to give it all the heat it needs, 528. So this way C1 is done. I still have some energy left here. So how much energy do I have left? It's 812 minus 528. So I have 284 left in the stream, right? So I still have 284 left. So let's have a look. So can I connect H1 to C2? 2.8, is it greater than 3.27? No, so I can't make this connection. Can I connect H1 to C3? Yeah, I can make this connection. So let's connect H1 all the way to C3. And we said this stream has 284 left and this stream needs 520. So I'm just going to transfer all the heat left in H1. This way H1 is done. And I still have, so C3 still has some heat requirements, which is 520 minus 284, which is 236, right? So C3 still needs 236, which I need to find in some other stream. Okay, so H1 is done. Let's have a look at H2. H2 has a CP of 2.38. And let's see, H2 with C1. C1 is done, so I can't connect H2 with C2. I can't make this connection. 2.38 is smaller. H2 with C3, I also can't make this connection because C3 is larger, right? So 2.38 is smaller than 2.6. So there are no matches for H2 now. Let's just leave it a bit. Let's just leave it for later. Let's have a look at H3. H3 has a CP of 3.36. Let's see if we can match it. 3.36 with C2. 3.36 is greater than 3.27, so I can make this match. So I'm going to connect the heat exchanger from C3 all the way to, sorry, from H3 all the way to C2. And H3 has 826. C2 requires 555.9. So I'm going to give it all the energy it needs, 555.9. So C2 is done. And I still have some energy left in H3. Let's see how much energy is left. It will be 806.4 minus 555.9. So I have about 250.5 left in H3. 250.5 left. So now let's see H3 with C3. Can I make this connection? H3 has 3.36, C3 has 2.6. So the CP for the hot stream H3 is larger than the CP for the cold stream C3, so I can make this connection. So I'm going to make this connection, connect another heat exchanger here. And H3 has 250.5 to give. C3 requires 236. So I'm going to transfer all the 236 from H3 to C3. This way C3 is done and all my cold streams are done. And for H3, I still have some cooling left or some heat left, right? 250 minus 236 is what? 14.5. So I still have some 14.5 left for H3. So again, since we're below the pinch, I'm going to add some cooling utilities. So let's add the cooling utilities to just finish off this problem. So for H3, I need a QC of 14.5 kilowatts to satisfy H3. So now it's done. And then for H2, I still need that because I didn't match it to any of the cool streams because its CP value is too low. So I'm gonna just cool it completely using a big heat cooler with 520 kilowatts, right? Or sorry, 523.6. It's going to be 523.6. Oops. So it will be 523.6 kilowatts in this cooler, right? Okay, so now let's check our calculation. So overall cooling utility here should match this number. Summation of QC will be 523.6 plus 14.5, and this is equal to 538.1. And this number matches this number, which means this network is valid or is correct, okay? So this is the solution for problem number 3, sorry. And yeah, just try it. If you're unable to do it, come to office hours. Okay, let's clear the screen now. Let's do number 4. Let's have a look at number 4. And again, number 4 is one of the problems which requires splitting a stream to make it work. But we're going to go through the steps and see how we're going to do this. So for problem number 4, I have 2 hot streams and 2 cool streams. Okay. Number 4, I have 2 hot streams and 2 cool streams. First of all, let's write our numbers. So my pinch temperature was 445 degrees Celsius. QH was 130 kilowatts. QC was 255 kilowatts, right? And let's draw our stream. So I have H1. It's going from 525 to 300. I have H2 going from 500 all the way to 375. I have, sorry, there are 3 hot streams and 1 cold stream. So I have H3 going from 475 to 300. And then I have 1 cold stream going from 275 to 500, right? Going from 275 all the way to 500. So we draw our streams. Let's draw the pinch point. So again, our cold pinch or our hot cold pinch is 445. Our hot pinch in this case is 445 plus 30. So our delta T minimum for this problem was 30. So it's 475 degrees Celsius. So let's draw the line for the pinch point. So in this case, I'm gonna have my pinch point right here. And it's going to be 475 for the hot streams. And for the cold stream, it will be 445 for the cold stream. So now let's clean up our diagram. As you can see here, 525 to 475, 475 to 300, that's fine. 500 to 475, 475, 375, that's fine. 475, 475, so there is no H3 above the pinch, right? So let's just draw it only below the pinch. So H3 only exists below the pinch from 475 to 300. And then to 275 to 470, 445, 445 to 500. That's fine. So C1 also exists. So C1 is good. I'm just going to redraw this line. Just give me some space on the pinch. So I'm just redrawing this line properly. Okay, C1, and let's go all the way to 500. Okay, so this is the problem which we're trying to attempt. And let's write the rules again. So we said above the pinch, CP hot has to be less than CP cold, and there is no cooling. And below the pinch, CP hot has to be greater than CP cold, and there is no heat. Okay, so before starting to match these streams, let's write our CP values. Let's write all these numbers, which will help make this situation easier. So I have CP for this guys it's 2, 4, 3, 6, and then I'm going to calculate the delta H's above and below the pinch. So delta H for each stream. So for stream number 1 below the pinch, so I have 2 delta H's, right? So let's look at this side first. 525 minus 475 is 50 multiplied by 2. That's 100. 500 minus 475, that's 25 multiplied by 4. That's also 100. 500 minus 445 is 55, right? Multiplied by 6. This is 330. On this side right here, 475 minus 300, that's 175. Multiplied by 2, this is 350. 475 minus 375, that's 100. Multiplied by 4, that's 400. 475 minus 300, that's 175 multiplied by 3. 175 by 3, this is 525. And the last one, 445 minus 275 multiplied by 6. This will give me 1020. Okay, good. So we have all our numbers ready. Let's start matching these streams. So I'm looking above the pinch now. CP hot has to be less than CP cold. So let's look at H1 has a CP of 2. Let's try to match it to C1 has a CP of 6. So this hot CP is less than this CP, so I can match them. So I'm just going to draw a heat exchanger from H1 all the way to C1 with, so this has 100, this needs 330, so I can just transfer all the 100 from the hot stream to the cool stream, and H1 is done above the pinch. Let's have a look at H2. CP is 4, 6, so 4 is less than 6, so I can do this match. Similarly, connecting them, this has 100 to give, this needs 330, so I'm just going to give all the 100, so this way H2 above the pinch is done. Then let's have a look at the C here. As 200, it needs 330, so I'm going to add a heating utility. Again, you can only heat above the pinch, you cannot cool, so be careful. And this heating utility is equal to 130 kilowatts, which matches this number. So we're good. And 100 plus 100 plus 130 is equal to 330. Okay, let's have a look below the pinch now. So below the pinch, CP hot has to be greater than CP cooled. And if you look here, all the CP hots, 2, 4, and 3, they're all less than 6. So technically, I cannot connect any of them. However, I cannot heat below the pinch, so I need to get rid of this energy somehow. I need to get rid of this 1020 somehow, right? If I decide to cool below the pinch, this means this is not the best heat exchange network. It's inefficient, right? So yeah, technically you can add a cooler, but it's extremely inefficient and you're just wasting a lot of energy. So the way to avoid this is I'm going to split this stream, right? So I'm going to split this into 3 equal streams. So instead of having one stream with a CP of 6, I'm going to split it into 3 streams, each with a CP of 2, right? So this has a CP of 2, This has a CP of 2, and this has a CP of 2. I split it into 3 streams with a CP of 2. I'm not doing any violation. I'm just, the mass flow rate, I'm just dividing it, splitting it into 3. And because this is actually MCP, just remember what we said in the slide, this is actually MCP. So if I take 1/3 M, if I reduce M to 1/3 its value, this MCP will be 1/3. So if I divide it into 3 equal streams, each of them will have a capital CP of 2. And how much heat will each one have? Each one will have heat of 1020 by 3, which is 340. So each of them will also have a 340 kilowatts to give, right? And this is the logic really of splitting. You can do the algebra, determine the split fraction, etc. But the overall, you can divide the 6 or whatever it is on a number of streams. Okay. So now I can do the matching because each one has a CP of 2, and 2 is, and the 2 for H1 is greater than or equal to 2, 4 is greater than or equal to 2, and 3 is greater than or equal to 2. So let's do the matching in this case. So let's have a look at the first stream here. H1 has 350, C1, the first split of C1 here needs 340, so I'm going to connect the heat exchanger from this guy to this guy, and this is equal to 340, and therefore this stream is done, and I have 10 left here. And then 400, I'm going to connect again from this stream to this stream, again 340, and this guy is done. And then I'm going to look at this stream right here. I'm going to connect a third exchanger here. So this has 525, this needs 340, so this will be equal to 340, 340. And then I'm going to make up the balances by using coolers below the pinch. Again, below the pinch, you can never heat, you can only cool. So I'm going to add coolers to make up the balance. So QC 340 from 350, so I need 10 in this stream. QC 340 from 400, I'm going to need 60 in this stream. And then QC 340 from 525, that's how much? This is 185, so I'm going to have 185 in this cooler. So this way I satisfy all the hot streams. Let's double check our numbers. QC 60 plus 10 plus 185, and this is equal to what? This is equal to 255. And this number is the same as what we got in our cascade diagram, which means that this network is valid. Okay, again, splitting, it's a very special case. On the test, I'm not going to give you a very complex split, but you might get a cute split like this, where you split it to 3 equal streams and you need to do the calculations. So try to absorb how to do it. Okay. Save this. Now let's clear out this guy. Let's do the last one. Sorry, problem number 5. And number 5 was a unique problem, right? And one thing about number 5, the solution we did last week for the cascade diagram was full of, not full really, we had a bunch of calculation errors. Hopefully you can catch it and get the correct numbers, but basically the correct values are T-pinch 370, this is the same really. The main difference is QH is 3,800, kilowatts is also the same. The main difference is in QC, we did a calculation error here, and the correct QC should be 160 kilowatts. So please just go back, verify it, and make sure you catch this error. Okay, let's draw our system. Sorry. So I have 5 hot streams and 1 cold stream in this problem. So let's draw it. Let's give ourselves some space to draw it. So I have each one here. It's going from 500 to 320. 500 to 320. H2 is going from 480 to 380. 480 to 380. H3 is going from 460 to 360, right? 460 to 360. H4 is going from 380 to 360. 380 to 360. H5 is going from 380 to 320. And there's finally C1, right? The only cool stream here, going from 290 to 670. Okay, so these are all our temperatures. So this is what? 500, 480, 460, 380, 380. And then 320, 380, 360, 360, 320. Right? 320, 380, 360. Okay, good. So now let's draw our pinch point or a line for a pinch point. Okay, so this is the cold pinch. Our delta T for this problem was 10. So our hot pinch was 380. So let's do this. So I'm just going to draw a line here down the middle to divide this problem into above the pinch and below the pinch. Okay. Here we go. And for the hot streams, there's going to be 380. And below the pinch is going to be 370. The pinch point. Okay, so now we have this line. Now let's clean out this diagram. Let's have a look here. 500 to 380, 380 to 320, that's fine. 480 to 380, 380 to 380. This doesn't make sense. Let's clean out this line. So H2 is only available above the pinch. So let's redraw H2. So that is only available above the pinch. Right, so it's only going from 480 to 380 and it's stopping here. H3, 460 to 380, 380 to 360, that's fine. 380 to 380, 380 to 360. So H4 only exists below the pinch. So let's clean out H4 and redraw it. So H4 in this case only exists below the pinch. This is H4. H5, 380 to 380, 380 to 320. So again, H5 also only exists below the pinch. Let's clean out this line as well. Let's redraw H5. This is H5 from 380 to 320 below the pinch. And C1, 670 to 370, 370 to 290, that's fine. So C1 is fine. So we have all our numbers. So now we're ready to do the matching. So before doing the matching, let's write our rules. So above the pinch, we said CP hot has to be less than or equal to CP cooled, and below CP hot is greater than or equal to CP cooled. There is no cooling here, right? No cooling, and there is no heating here. Okay, good. So now let's write our CP values. So CP, is it? It's 6, 4, 6. And then we have 20, 12, 18. Right? I'm gonna write them on both sides. Yeah, it doesn't matter. 6, 4, 6, 20, 12, 18. Okay, so these are the CP values for all the streams. It's the same numbers. Second thing I'm going to write my delta H is available, or the amount of heat available in each stream above and below the pinch. So above the pinch for H1, I have 500 minus 380 multiplied by 6, so this is 720. For this guy, I have 400. You can verify these numbers. This guy, I have 480. This doesn't exist above the pinch. And for this guy, I have 5,400 kilowatts above the pinch. Okay, let's have a look below the pinch. For this guy, I have 360, right? There's nothing for the second stream. Third stream, I have 3080 minus 60 is 20, minus 6 is 120. For this guy, I have 400. Here I have 380 minus 320, again 720. And finally, for this stream, I have 370 minus 290 by 18. How much is that? 370 minus 290 divided by 18. This is 1440. 1440. Right, so now we'll have all our numbers. Let's start doing the matching. So I'm going to look above the pinch first. Again, CP hot has to be less than CP cool. I'm going to look at the first stream. H1 has a CP of 6. For cold stream has a CP of 18, so I can do this connection. And actually, if I look at H1, H2, H3, 6 for 6, they're all less than 18, so all these connections are valid. So let's just connect all of them, or let's see how much energy we have. So 5,400, 720, so I'm going to transfer all the 720. And H1 is done above the pinch, and then H2, same thing. 400 from what's left. What's left is definitely greater than 400. So I'm going to transfer all of this, and H2 is done. And then finally, H3. I'm going to transfer all of the heat here. 480 and H3 is done. And then I need to make up the balance. So how much heat is left for in C1? 5,400 minus 720 minus 400 minus 480. This is 3,800. So I'm going to add a heater here. QH with 3,800. And this number matches this number. So this connection is valid. Okay, let's go below the pinch. And let's have a look at our streams. So H1 has a CP of 6. So CP hot has to be greater than CP cooled, right? For yeah. So for the system below the pinch, CP hot has to be greater than CP cooled. Okay, let's have a look here. And again, this is a similar type of problem. Or if I look at my streams, 6, 6, 20, 12, 18. Only 20 is greater than 18. So let's make this connection, first of all. So I'm going to connect here. I'm going to transfer all the 400 available in 20. Okay, so this stream is done below the pinch. And I still have 1,040 left here, which I need to get rid of somehow because I cannot heat below the pinch. So in this case, I'm going to do a split stream. I'm going to do a split stream where I'm going to, so 18, I can split it. I can split into 3 streams actually, and it will be fine. So this is what we're going to do. So we're going to split it. Let's see. So we're going to split it somehow. So you can calculate the split fraction, but the math will work out. I'm going to let you calculate the split fraction by yourself. So I'm going to split it somehow into 2 streams where the first stream has 720 and the second stream has 320, right? And the logic here is I'm just splitting it into 2 splits. The overall energy is equal to this, and then you can calculate the CP in each stream, but the CP in each stream will be lower than these guys. Take your time and calculate it. But and if you can't do it, just come to office hours. And the logic here is I'm going to connect this stream to this guy, 720, get rid of this, and then I'm going to connect this stream at the top all the way to the other split. And transfer the 320. And of course, there are many different ways to do the split, and you still get the same thing. Okay, we're going to get the same cooling utility. So these 2 streams are done. Let's make up the balance. So for H1, I took 320 and I have 60, so I'm going to add a cooling utility of 40. H4, H5 are done. There's no H2, so H3. I didn't do any connections for H3, so I'm going to add a cooler to just completely cool H3. And H4 is done, H5 is done, and then C1 will be done using this because 400 plus 720 plus 320 is equal to 1440. Right, let's verify this. 400 plus 720 plus 320 is equal to 1440, so C1 is done. And now if we check the overall cooling utility below the pinch, 40 plus 120 is equal to 160, so this network is valid, okay? So that's the end of the homework. Please take your time and try to replicate these problems, try to solve them. If you have any questions, please come to office hours. Make sure you understand the process and how to repeat it. It's just an algorithmic type of procedure, but get comfortable with it because it's very important to know it, and your exam will completely come from these types of problems. Thank you very much.